So we have y equals x squared, which we know is a parabola. We know that they meet at 1, right? Because when x is 1, y is also 1. You could do a quick check, x squared equals x cubed minus x squared equals 0, x squared times x minus 1 is 0, so x is either 0 or 1. So that makes sense, they meet at 0 or 1. The question is who's on top, who's on bottom? Plug in anything between 0 and 1, like a half. 1/2 squared is a fourth, 1/2 cubed is an eighth, and this guy's smaller, so the x cubed is actually on the bottom. So you have y equals x cubed on the bottom, and y equals x squared on the top. But we're going around the line x equals 1, which is this line here, which looks like the y-axis. And if we're going around the y-axis, we want our function solved for x. So I'm going to say that x is root y, and x is the cube root of y. And so the bottom guy is the cube root of y, and the top guy is the square root of y. And I'm looking at that region between it, and I'm trying to spin it around that line y equals 1. So around that line there. So when I go to draw my radii, this is a really ugly picture, I'm going to just draw it again. So we've got y equals x squared, y equals x cubed, around sheesh, it's hard to draw, around 1. There we go. So when I go draw my radii, I start at my axis of rotation, that 1, and I draw until I hit something. I hit that y, the cube root of y first, but I can go farther. I could hit that y squared, or the square root of y. So there's 2 radii here, and because we're going around a funky axis and not just one of the normal y or x axes here, we have to be very, very careful. It's not just going to be our function. So our volume is going to be this length here. That radius is not the full 1 long, right? That would be 1, but it's 1 minus the length of the function. So it's 1 minus, and that one there, the outer one, is the square root of y. So we have pi times that radius squared minus the inner one. And again, the inner one's not 1 long, it's 1 minus the length of the function, so 1 minus the cube root of y squared dy. And because this is in terms of y, I want to know what my y's are doing. So if the x's are going from 0 to 1, the y's, if I plug in a 1 for the y, it looks like they go from 0 to 1 as well. Coincidence, you have to be very careful because they're not going to be the same all the time. So y is going from 0 to 1, gotta love this setup. Excellent. Now we just have to solve. So if I go 0 to 1, if I FOIL this out, I'm going to get 1 minus 2 root y plus y minus 1 minus 2 times the cube root of y plus, it's going to be y to the 3 halves dy. And if I clean this thing up, 0 to 1, 1 minus 1 goes away, and this is minus 2y to the 1 half plus y, minus minus will make a plus 2y to the 1/3, and then minus y to the 3 halves. Alright, fine. And so now take the antiderivative of each piece. Ugh. So it's minus 2 y to the 3 halves times 2/3 plus y squared over 2 plus 2 times y to the 4/3 divided by, times 3/4 minus y to the 5 halves times 2/5. And that 2 should have stopped there, right? And so this from 0 to 1, thank goodness we have a 0 and a 1, right? That's okay. So we'll put in that pi, and if I plug in a 1, I'm getting negative 4/3 plus 1/2 plus 6/4 So I guess 3/2. 3/2, and then minus 2/5. Really don't feel like adding fractions. Going to be incredibly lazy. And I'm going to do -4 divided by 3 plus 1/2 plus 3 divided by 2 minus 2 divided by 5. Math, enter, enter. I get 4/15. I get 4 pi over 15, and I cross my fingers. They just have pi over 15, so I'm off by 4. Let's see. So, -2 y to the 1/2 plus a y plus 2y to the 1/3 minus y to the oops. Darn it. I should check it before I do the rest of it. That's not 3/2, that's 2/3. I got it when I did a cube root of y squared, and the cube root of y squared should be 2/3, not 3/2. So that's going to make this guy a 2/3, which is going to make this guy a 5/3, which should make this guy a 3/5. So now that'll make that guy a 3/5. And so if I change that, second enter, 3/5, math, enter, enter, yeah, pi over 15. That's our guy. Great.